Okay, so at first, today is another part of the learning one. As you can, I think you can still remember that we have, um, I'm not sure, it's about the machine learning. Um, okay, normally, um, today we have just only one equations, only one equation. That is, I think it's super simple for all you. It's very simple one. And it's like the way that we did last week, that the equation is like the way that you update the v vector of the particle. Same idea, almost same idea. At first, if I talk about ML or the machine learning, you have to think about there are three main categories. The first one is supervised learning. This one is like very popular. Um, it's about the way that you can have the vector input vector, and along with the input vector you must provide, or the user must provide the label or the target one, the target values of that vector. For example, you provide a vector of PM 2.5 for previous, this one. You provide the PM 2.5 values of the previous five hours, and you want to know the PM 2.5 of the next hour. For example, this one is the target one. So you have the target that with the input vector. Okay. Uh, if you have a board of checkers, for example, you have a board like this. For example, if you have the board of checker, and oh, sorry, it's like this. Um, there should be someone that tell you this one, this move is good or bad. Someone should be able to tell you. Okay, so this is a kind of the supervised learning. Another one is we call it the unsupervised learning. For the unsupervised learning, you don't have the label along with your vector x or input vector. You just have these values. And you may have the same size of the vector of the PM 2.5 values in a period of 5 hours, for example. And then what you want to know is, are there any groups that you can merge, or you can find the situations of 5 hours that is very close to each other, or can you group the weather like 5 hours before, or maybe you can shorten them, like just 3 hours is enough, for example. Okay, so it means that you don't have the label in the unsupervised learning. But what you can know is what is the patterns of a group of the PM2.5 conditions. Okay, and the last one is this one, the reinforcement learning. What's the idea of reinforcement learning? The idea of reinforcement learning is it's I draw this board because it shares some purpose here. Guys, please look at this board. And of course, that cannot like can we cannot have someone that can tell that this board situation is good or bad if it doesn't have the immediate reward at that time. For example, if you move white from this, if you move white from this to this, so the problem is, yeah, maybe it is you get an immediate reward that okay, our the number of um our the number of whites is greater than the number of black. So it's like, yeah, it's better. Okay. So that is like one of the immediate reward. But if you don't have the immediate reward, for example, if you move white from here to here, the number of whites and blacks still same, right? So we don't have some immediate reward for this move, So maybe you have to wait for some move that, for example, you move here, here, and black move here, and then sometimes when you move from some board position by some action, you have a board position, right? And then you have some actions that you can take from that board position. But you don't have the immediate reward at that time. You don't know the label. Is it positive or negative? Is it good or bad? You don't have. So the idea is quite simple. You have to wait for some immediate reward, or you have to wait for some reward. And then all moves that achieve the good thing or the good reward should be good one, right? If you move, I think when you are a kid, when you play checkers or chess with your friends, of course in some first few games, I think that you couldn't win, right? And you have to play with your friends again and again and again. And you can remember that if this kind of situation happened, it means that you shouldn't move that way. You have to move this way. So it means that once you learn something, you can use the reward from the end state or some very fast state from the current status, and move that reward back to some board position. Yeah, this board made us win. So we should have like some score or some reward for that action of some particular board. Board and action. So that one is we call the reinforcement learning. you don't have the immediate reward, but you have the sequence of action that got something, got the reward, or maybe it can be like the negative reward or the punishment. If you win, all moves that lead to the wins should got the result, the rewards. But the reward should be like scattered equally or distributed to all actions equally. But it should be like something that the one that lead to the immediate reward or the positive reward should be like this. If you have more like many actions, and in this board status, you have the board status 1, board status 2, board status 3, board status 4, board status 5, and this is one action 1, action 2, action 2, action 3, action 4. So, and you got the reward here. What does it mean? It means that some reward should be distributed to this action, to this action, to this action, and to sorry, and to this action, right? And this reward, reward 1, 2, 3, 4, 5. The reward that is closest to the immediate reward 1 should be the highest and should be distributed and like reduced. Okay, should be decreased by some values that we always use some function like alpha values time immediate reward, and then for this one we times with another alpha, so it will be alpha square. Okay, something like that. So if alpha is less than 1, so it is like 0.8, 0.64, 0. Something like this. Something like this. Okay, so it's like you have some factors that comes with the reward that you get from some state. Like if you get the reward here, this action should be the one that got the biggest portion of rewards, and this one should be a little bit lower, and this one should be the lowest one. Okay, so we should have an equation. To find the immediate reward. To find the reward for each action. So guys, if we have a grid, sorry. For example, if we have a mesh like this, or the board like this, and you have some immediate reward 1 here, and you have the negative reward like a bomb here, for example, and your goal is here, and your start state is here, for example. So if you have an agent, and your agent can work like randomly from the start state and can move left, right, up, and down. Okay, so your agent can move to some place, like if can move here, right or down, And once it moves right, it can get the immediate reward here. So I think in this case, your agent should love to move right, right? And then it can randomly move down or like right again, or it can move back to start again. And then uh, if it move here, your agent is, for example, your agent is here, it moved from here to here, and then move down. It doesn't have any reward here, but if it moved from here and moved right, it got the negative reward or punishment. So it should be the values or the some values of this state to this state should be lower. Okay. So from here it shouldn't be moved here, and to prevent the agent moving from here to here, this action the agent that moved down should guard the punishment also, right? Because this action from here to here can lead to the negative reward, right? So this action to move this one down should have some penalty also. So we should prevent this move. So we should like move from here to here and then to here. So finally, your agent, once you let it randomly walk in this mesh, so it will move like this from start to goal. Okay. So guys, now let's check this equation. Okay, so we call it the Q values, but the Q values should be the values of not only action, but it should be the values of both state and action. It should be the values of state and action. So you can update the state at time t and action at times t using the Q values from the previous state. It means that you can store the original one, okay? But you have to this alpha, and you have to lower these values by alpha, coefficient alpha. What does it mean? What does it mean for this term? This one will be right. If I write it just only this part, can you see? It must be 1 minus alpha, right? Times the Q values from the previous state. Okay. But not only these values, you can have the immediate rewards from next action. and plus gamma of max action. This is the max values of action of the Q of ST plus 1 with action A. So there are two parts. This is the one that is like the like the portion that should be lower by when the times pass. Okay. In the next step, it should be this one should be lower, and then uh and it should be added by this value alpha times immediate reward plus gamma of max of A, max of the Q values that achieve the highest the highest action that achieve the highest Q. Okay. Okay, so once you finish, now it's time for us to play with this match. Okay. Okay, I'll start with at first we have to define all if this is goal and this is start, and okay, so if this one is immediate reward by plus 10 and this one is minus 20. Okay, so once it reach goal, the game's end. So you don't have the arrow back from goal to the adjacent cell. If this is cell number 1, number 2, number 3, number 4, 5, 6, 7, and 8. If your data is look like this, okay, now guys, if all of the queue start with like the easiest one, like if I start with all of them to be 1 1 1 1 1 1 1 1 and 1 and 1 and 1 and 1, okay, all queue of state 1 and action right is 1, queue of 1 and action down is 1, queue of 1 and no, you don't have up or left, so queue of 2 is of right is 1, queue of 2 left is 1. Oh, you must have this one also. Okay, so all of the Q values, Q of the state along with the action must be all of them will be one. First one, in the first stage. Okay, guys, and then this one, you should have some policy. For example, if you assign this agent to walk randomly, if you assign this agent and you say that okay, you have to walk randomly from state 1, and finally once you reach state T or state 8, the game's end, and you repeat doing it again and again. So the idea is now your agent can move, but sometimes when you already learn something, sometimes you can move not randomly, but move by some policy that you can just learn from the previous iterations. For example, if you notice that okay, it with some at some state you shouldn't move to like the negative reward or the punishment state, so that's fine. You can avoid that move by checking the Q values and don't move randomly. That's fine, but it depends on the one who trained this. Okay, so at first, if you allow them to move randomly, so at first, guys, when you move this agent, to state 5, it means that now you're trying to update the Q values of state 1 down to be, for example, if your alpha is 0.6, if your alpha is 0.6, so 1 minus alpha is 0.4 and your gamma is 0.8, for example. So if your constant, all of your constant is like this, so the first term is must be 0.4 times Q of right plus you don't have the immediate reward, sorry, gamma is 0.8. So this one, oh sorry, your alpha is 0.4 times this one times immediate reward in the next step. So you don't have the immediate reward of the next step. Plus gamma 0.8 times max of Q in next state. Next state, guys, look at this. Next state here is you move from state 1 to state 5. So next state is 5 and max of 5, max of all action is 1, right? All of them still 1, right? So zero point 0.8 times 1. So Q1D should be now, it is 0.4 times 1 plus 0.32, right? So it must be 0.72. So now for this move, it changed from 1 to 0.72. This move can change the values of Q, okay, to be 0.72. Next, your agent now is in this cell, right? And then you can randomly choose it. So if I choose to go right, so guys, Q of state 5 and go right, will be 0.4 and then it is 1 plus 0.32 again, right? Because all of the states, all of the actions here, the highest one is 1, right? The highest values is 1, right? So it's same. So now this move will be changed to 0.872. And now your agent is here.
Y alpha is equal 0.4 นะคะ
อุ๊ยขอโทษค่ะขอบคุณมากค่ะ 0.6 ขอบคุณค่ะขอบคุณค่ะ Okay, so once you are at state 6, and then you randomly choose and you move up. Look at this. So Q of state 6 and up will be 0.4 times 1 plus 0.6 plus times immediate reward of the next state is 10 plus 0.8 and higher still 1, right? So now Q6 up will be 0.4 times it is 6.48. It is 6.88. Okay, so you're moving up now is changed to 6.88. And next, when you are here and you move here, randomly choose and move here. So when you are in state 2 and you move right, when you are in state 2 and you move right, and then it is same. Your immediate reward is minus 20 plus 0.8 times 1. So it is so this move will be this one is minus 2 11.12. Okay, and then next if you move from here to from here to here, you are at state 3 and you move right, it will be 0.4, right? Same. 0.4 times 1 plus 0.6 and then no immediate reward and 0.8. So this one is 0.88. This one is 0.88. And then you move down. Fall down is 0.4 times 1 plus 0.6. And then immediate reward is 100. That is the end. And if you don't have a cue from action from this, just use this immediate reward. That's fine. So this one will be 60.4. This is the first round. And then you can move your agent back. And now you have some information. You already have some information. Look at this. If this time, if you are at state 1 and you move right, what happened? So Q of 1 and move right will be 0.1 times 1, right? Because this you never been here before, never used this action before. So this one is 0.4, and then guys, 0.6 times immediate reward is 10 plus gamma times max. From state 2, what is max values here? Max value is 1, right? 1, right? Because you can, this one is very low. This one is 1. So this one is 6.88. So this move will get 6.88. And then to here, guys, to here. Can you see something here? You have Q values of some actions, right? You have Q values of some actions. So guys, at the first or like in early stage of your move, early iterations like this, maybe you can randomly move. But I think you can see that some move is bad, right? If you move right from this state, the Q values is minus 11.12. That's quite low. But if you do it, maybe you can use like a randomly move. So if I move down here, that's what happened. Q of state 2 and down will be 0.4 times 1 plus 0.6 and no immediate reward plus 0.8, and max of this state is 6.88, right? 6.8. 3.7. So this is 3.7. And then from here, you move right again. You move right from here to here. So Q of 6, right? 6 and right. 0.4 times 1 plus 0.6. No immediate reward plus 0.8. And the highest maximum of 7 is nothing, right? No. So it is 1, still 1. So this is 1. So it is 0.88. This one is 0.88. And once you are at state 7 and you move right, randomly move to the right. So immediate reward will be 7 move right. So immediate reward will be 100 plus 0.6 and no state move. So it is a 60.4. So this one 60.4. Okay. And then once you reach the goal, you can move back. And then now you have more information. You have more information. For example, comparing between this, move to the right, got 6.88 and move down, got 0.88, right? So in some move later, in some move at maybe next 10 iterations, maybe if you want to move by Q values, you will move to the right. Okay, guys, next. So if I randomly choose, randomly choose this one, move down, Q1 down is, the original Q is 0.88, 0.4, 0.88 plus 0.6 and no immediate rewards, right? No immediate rewards. And the highest one is 0.8 times 1. $0.83. So now it changed from 0.8 to 0.83. And then once you are here, you can move from here to here. You can move back also, but in this demonstration, I think moving forward or never go to the repeated state should be better. Okay, so 5 to 6 Q5 and right will be 0.88, right? So it will be 0.4 times 0.88 plus 0.6 plus no immediate reward at state 6, right? So no immediate rewards at state 6. So it is 0 plus 0.8 times the highest, the max of Q. Which one? 6.88, right? 6.88. The max Q is 6.88. So 6.88. .77. So this one will change. 0.77. It's like become a little bit lower, right? Because now at state 6, no, the highest one is 6.88, not 0.88, sorry. 6.88. .34, 3.94. Okay. So then moving to the right, this one, 6 and right. Now, at this point, you will see something strange. Q of 6 and right will be 0.4 times the previous one. The previous one is 0.88, right? So it will be 0.88 plus 0.6 plus no immediate reward plus 0.8 times the highest one. The highest one here is 60.4. Very high. 60.4. 60.4. $29.34. So it is 29.34, guys. Very important at this point. 29.34. Guys, can you see something? Why this one becomes very high? Why? Because this one, right? Because these values, right? Now, can you see? When you move from state 6 to 7 and 7 to gold, the immediate rewards of gold pay back here and back now, right? Right? Okay, now if you are at state 7, and you move here, state 7 and move right, it is 0.4 times 60.4. 60.4 plus 0.6. Immediate reward is 100 plus 0.8 times 0. It is 60. $84.16. So this one will change to 84.16. Okay, so now your reward from state 7 is now it increased. Okay, guys. Now if you are at state 1 and you move right, randomly choose and move to the right, what happened? One to the right will be 0.4 times 6.88, right? 6.88 plus 0.6 times immediate reward plus 0.8 times highest. Highest of state 2. Highest of state 2 is 3.7, right? So it is 3.7. 3.7 is 2.1, 2.13. Okay, so now, oh, sorry, it's wrong. It is 4.53. This one, 4.53. I would like to move down to show you something. If I move down, guys, please guess the values. If I move down, please guess the values. It is 3.7, right? Times 0.4, right? If I move down, it is 3.7 times 0.4, right? Plus immediate reward, no. But the highest is now 29.34. And these values will be used to added something to this 3.7, right? So this one will be higher. Okay, so if I move here, this one, if I move here, but to the right, what happened? This one will be lower, right? But actually you times it by 0.4, so it is higher, right? Higher. But you have another immediate reward and not so high values here, right? So the immediate reward will have some effect with this one, so it will be again negative. It will increase again. Okay. And this one, when it moves to here or move to here, the reward here will be okay. So the reward will make this one better. Okay. So guys, please guess. Once you finish, which one is the best route? If you are an S1, so comparing for this one to this one, I think this one should be better because it's got more immediate reward from this, right? And then I think you may not move to here. So you have to, because this one will be higher and higher, right? Right? So this one, you move this to this and to this, and then this and this. Is it good? Yeah, this is the best one. Okay. Let's take a break first, and then I have some code to show you. ซูมเบรกแป๊บหนึ่งนะครับสัก10 นาทีนะครับ Hi, so I'm sorry, I forgot to open microphone and videos. Here, this one is same thing as the one that we had. We are done before. Look at this. I create the immediate reward cell like this. Same as the one that we had in our data, in our note. There's the first row. In the first row, you can see that we have 10 in the second column and minus 20 in third columns, and in row, the bottom rows and the rightmost one, it is 100 immediate reward. Guys, to move the tables, I call it move table. Move table can be for operations 0, 1, 2, 3, 4, and for move zero is move row -1. It means that move up. Okay, zeros mean move up, and the second one, add 1 to the row, so move down. This one which move down, the second one, and the third one is add -1 to columns, so move left, and the last one is move right. Okay, so this one I call it move table. And guys, if I test start with first move, only one move, Only one move. This one. This one is the current state. Yes, current state I set at to be row 0 and column 0. So it is in the top left. And step is 0. And while current state is not equal to the row I or row minus I, or it means that y is not reach the bottom right. Okay, while it's not reach the bottom right, I choose randomly. I choose randomly one of these 4 operations, and step is 1, and this one is the next state. Next state. If the next state is out of bound, it's go beyond the cell, like go at row -1 or column -1 or row 2 and column 4, for example. Okay, so this one will yes. Okay, so I set the immediate reward to -10. I don't block it, but if it hit the wall, can you imagine? If it hit the wall, it's in the first row, but it still go up. So immediate reward is -10. I don't tell the agent to, okay, if you at the top row, you cannot move up. No, I allow them to move up, but set immediate reward to -10. Okay, and then set the Q values here. This one is the same thing as we did. I set this one to be the reward, immediate reward of each one. And then can you see the Q values? One is the Q values plus this one, W times reward plus gamma times max of next state. Okay, next state, Q and action. Which one is the highest of the Q1? And then minus Q. Same thing as we did, okay, in our equation. And then current state is the next state. So guys, this one I just moved only one round. Only one round. I have to reset our Q and values. This one round. So you can see that for the first, this one is the 4 operations Q values. Up, down, right, left and right. And this one is Q of 0, 0. Row, top row, first column, top row, second column, okay? Top row, third column, and top row, last columns. Bottom row, first column, bottom row, second column, bottom row, third column, and bottom row, last columns. So you can see that some of them increase like this. Where is it? It is the bottom row, third columns. So if it's moved right, it will reach the goal. Okay, so it reached the goal. So it get 0.9. Okay, so this is the highest one. This is okay. Okay, so next I will try to move not one, but I try to move 100 round. But guys, you can imagine that 100 round is like you have eight states, and in each state it is like 32, right? So each state has 4 operations. So your Q table size is 8 times 4, right? 8 times 4 is just 32 values that you have to update. But for just 100 move, it's like not so, I think it's not so, not enough. But at this level, you can see something. If you are at the top rows, if you are at the top row, because this one is the, guys, can you imagine? This one is the starting point of your agent, right? The top left corner. So can you see? -10 if you move up and -10 if you move left. Okay. Because this is like, okay, you always visit this state because this is the start state at state 1, right? So if you choose move up or move left, it will be like, yeah, you do it many times, so it will reach the immediate reward -10. And you can see that for the second, yeah, for the second column in the top rows, you cannot move up. Move up is -10. Okay. Okay. And you shouldn't move right. Because, yeah, if you are here, if you move here, you will get -20. So this one should be very low. Okay. But guys, if you are at the bottom rows, the third columns of the bottom row, what should you do? Move right. Right? Move right. Because you always, if you move right, you will reach the final, the goal state. Okay. If you are at the top bottom rows, you should move right also. Bottom row, second columns. Bottom row, second columns. Can you imagine? Bottom row, second columns. Columns, if in our iPad, it is the state number 5. Okay, but here, if you are in the bottom row, move up or move right. Move up, you will get immediate reward, but move right, you will get the reward from the goal state. Okay. So now let's allow it to move 1,000 round. Now it reached -10 already. -10 already. This one is almost -10, -7. This one, oh yeah, it's reached -10. This one is reached -10. So you cannot move left. But this one, if you are bottom row, you cannot move down. Okay. Okay, so yeah, that's one. So guys, let's check what happened in this case. If you are at column top row, how can you move? You can move down with 20, around 20, right? 20. But if you move right, it will be 30. So you should move right. And then move right if you are still in the top row, but second column. So you are up here. Which operation you should move? You should move down. Okay. You can go back to the left or go to the right, but it's just only 10. But this one is 30, 35. Okay. So you should move down. And then you are at the bottom rows, second columns, right? So here, how can you move? Yes, you have to move right. Okay. And then you are in the bottom rows and in the third column. And here you can see that it is 90, almost 100. That is immediate reward 100, right? So if you are in the bottom rows, the third columns, you should move right. That's all. Okay, ไหมครับ Zoom, do you have any questions? If you don't have any questions now, I will allow you to change some dimensions. Do you want something? ครับผม
ผมมีคำถามที่ไม่เกี่ยวกับอันนี้แต่ผมแค่อยากถามว่าพวกโน้ตนี่อาจารย์จะกับ
อ๋อ
สตา
เดี๋ยว
ร์
อัพให้เถอะอัพให้นะครับเดี๋ยวอัพให้ครับ
นะครับใช่ครับเพราะว่าเปิ
ข
ดไปมัน
ออภัยเดี๋ยวจะอัพให้นะครั
นะครับ
บ
ขอบคุณมากครับ
ขอบคุณขอบคุณครับขอบคุณมากครับที่ถามที่ทวงไม่ใช่ที่ถามขอบคุณมากที่ทวงนะครับเดี๋ยวจัดการให้นะครับ Okay guys now I would like to make it to be 3 rows 4 columns 3 row 4 columns and which one to yeah where you want me to add some immediate reward I think I would like to move this to here minus 20 here and then add another one with row 2 column 1 to be 5 yeah okay so it can move I think it can move here and down okay go along the top rows and then the rightmost columns it will reach the goal and can avoid the negative reward here โอเคไหมครับ okay so or it can move here and then go down to this one and once it reach this so you can turn right let's check okay let's check okay now it is like 3 rows guys at first where you want to move you should go right yeah go to the right one here go to the right one and then you can go down or go right or up left or right okay left or right but you can go down here so if you go down you reach this row right this row the second column so where can you move go down again right go down again so you will reach this second columns and then you cannot go down anymore right because it's minus 10 already you can go left you can go up you can go left but the best is go right okay and then again once you are in the bottom rows you can go right and finally you will reach the goal state do you want me to tell something else okay so if you don't have any questions relating to these examples I have another one that you can try by yourself I generate some data like this with 8 row 8 columns 8 row 8 columns and then has the immediate reward 100 here this is very difficult to be reached because it's like I randomly generate negative reward -1 okay so and then I try adding something here yeah I add immediate reward 50 at some point okay but it's too difficult I think -10 okay yes so I think that it should be like this so in this board it should move somewhere like this okay so I train it 100,000 round that is maybe is not enough Yeah. And then now we cannot see the part anymore, right? So I just write the program to show you the part. So this one is the moved. Guys, can you see? Yeah, it moved this way. One here, and then move right, and then down, and then move right, and then up and down. Why? Because it like go up, and then the best way is like to move back to that immediate reward again and again. So you can imagine that if it moved here, so let's check the almost the last row, this one, almost the last rows, and this one. If you are here, almost the last rows, and this one, this values. Guys, can you see? From this immediate reward 50, it almost equal. Can you see? It almost equal. So actually, if you can move to the right, here, if you can move to the right, your right one will be here, and then it will go left again. But if you have something that you shouldn't move back to any repeated state, this one will be avoided. And then so you can move right. And finally, once you move right, so this one, so you can move up and down and up here. Okay, so I didn't add the mechanisms of avoiding the repeated one. So if you can see, I think you can, it's stuck here. It's stuck here. It doesn't reset the Q value, so it's trend again. Add the values are like continue from last values of Q. So let's it work here. Okay, guys. That is yes. Oh, I just add another zero. Add more round. Okay, guys. From this, I will add a link to Q Learning Engine. This one is just a demonstration. It's not the one that should be in the exam paper. So if you are at this simple Q learning, the one that we study here, yeah, I think it's finished already. No, it's still stuck somewhere. Guys, look at this. This one is 60, 78, and 60. It is this point. It is this point. So you can move down, or you can move right, or you can move left. All of them are fine. Okay. But if you avoid this one, so you can move here or here. If you are at this point, you have moved down. Okay, and if you are at this point, you should move right. So you will reach the goal state. Okay, guys, there is one thing is about the gym. Gym is, I think you already know OpenAI, right? Because now OpenAI is very, very famous in ChatGPT, right? But before that, it launched OpenAI Gym here. It's like the way that you can work with the robot is reinforcement learning. You have many environments. There's like the small task, like the classic control, or the toys text. So you can So there are many things relating to Q learning, but the one that can you see here? OpenAI, they allow us to do a lot of things here. GPT-4, DALL-E. But what we have to do here is Gym. So I will show you another link. Gym Mountain Car. This one is the mountain car. So guys, it is the one that like the mountain, and your car is like the car with no engine. You can push the car to the left, to the right, or do nothing. But guys, because it has no engines and you have like limited force that you can push it to the left or to the right, and you can do it just only 200 steps, just only 200 steps. So the observation space is the position. There are just only two values of the one that you can observe from this environment. The first one is the position in x-axis. So you don't have the y-axis, you just have the x-axis, and the other one is the velocity at that point, the velocity of the car, and the action space is, can you see? Or if you 0, 1, and 2, 0 is go to the left, try to push it, accelerate it to the left and to the right. It's 2. Number 2 is to the right. Try to push them to the right. And if you use 1, it means that you do nothing. Okay, so the car will fall by the gravity. And when you reach the point, the point is the goal is here. So sometimes you can think that you can move to the left first and then do nothing, and until it reaches the highest, you go to the right and move left again, and then go to the right again to make it reach the top of the mountain. So this one is quite interesting. The reward is when you reach the flag at the top right. Okay, the start state is randomly between 0.6 minus 0.6 to minus 0.4, like it almost here at the it is at the lowest point of your mountain. Okay, it will end at 200 or reach 0.5. Okay, so guys, this one is the Q1. So you can see that once you use, if you want to use GIMP, you just import GIMP and make the environment mountain curve v0, and then you reset it, and then step 0, you will get the one return. Can you see? This one is the position in x-axis, and this is the velocity. The velocity is go to the left. Okay, and then it's not reach the goal. And minus 1, I'm not sure what is it. I cannot remember exactly. Okay, so this one is run by episode and check the average reward. You can see that the reward is still minus 200. It doesn't reach, because the reward is like the highest one. The one that you can see is here is divide. Guys, look at this. This one for each iterations. Look at this. There is one reduction, but I'll tell you later what is it. And this one is the number state. Because the values that return from this environment is the continuous values, right? So we divide it into the number of states that is like 10 and 100. So I will show you later what is it. And here it try to discretize the number of states to make it like not because you must use the Q&A, right? Q, the state of Q now, state of Q, not only the one that we had before, it's same as the one that we did in our Colab, that there are 2 dimensions. But in our example, just 3 rows, 4 columns, or 8 rows, 4 columns. But this one is discrete number of X and V. Okay. And then for each state, it will have 3 operations. In our example, it has 4 operations, right? But in this case, there are 3 operations. Now it becomes better. Yep. So this one is the average reward. So you can see that we do it better and better. Okay, at episode 5000. So I will give you another this one. This collab is better. So I use it to explain many things. Okay. So at first, this one I will do, guys. I will stay still for 100 steps, and then I move to the right. Another 100 steps. So let's take a look at the result. So what we have here is, in the first 100 steps, it is like this. So you can see the first element is the position in x-axis, right? And the second position is velocity. So it's like almost like stay still because the velocity is very low until we try to move it to the right. Can you see? We try to move it to the right after 100 steps. This one should now is moving to the right. Can you see the number of our x is decreasing, right? To the right, to the right, to the right. And the velocity is like higher and higher and higher. But now the velocity is slower. Slower until it go back. And because it's like you make it like stay still and try to move to the right, and then no enough force to keep in that state, so it will go down. So this one will go down. Okay, so So you can see the number, the, the situation. Guys, now I use the, can you see the height and low times 10 and 100. So the number of states now is like we have 19 times 15 velocity and x. This is the highest and this is the lowest. Highest is 0.6 and lowest one minus 1.2. And this one is velocity highest and lowest. So we divide it into 19, 19x and 15 velocity. And then we do it 5,000 round, and then I render the image here, and you can render the image after I render after like at the state that almost at the end of this training. But after 4,000 round, I set the values now is not random anymore, but try to do the best cue that we have already learned. Okay, so I will show you my cue learning. I will copy the code to this one to make you can see. Moment นะครับ แปลกอ่ะน่าจะถูกครับงงเหมือนเป็นคนละเวอร์ชั่นกันยังไงไม่รู้แปลกมากดันมันไอตัวดันในโคแลบเนี่ยเอ่ออ๋อมันไม่ได้ install ตัวจิมใหม่มันใช้จิมของโคแลบไอ ดันมันอยู่พารามิเตอร์ตัวที่สามแต่ว่าไอของผมเนี่ยนะครับ อันนี้มัน install จิมใหม่ จิม Classic Control ก็เลยกลายเป็นดันไปอยู่พารามิเตอร์ตัวที่สี่นะครับ ก็รอนิดนึงแล้วกันนะครับ แต่ว่ามัน